Morning, everyone. Hi there. So today what we're going to do is we're going to deal with conjugates, and we talked about what conjugates were before, and then we're going to use them to get rid of the square root from the denominator. So we're going to go through some rules from Algebra 1, how we solved them in Algebra 1, and in Algebra 2, how do they got more difficult, and how do we deal with them now, okay? So here we go. Sorry, someone just came in. Alright, so here we go. So if we looked at square roots before, so if I give you a square root of 3, and you say, you know what, I don't want that square root there. The way we get rid of it is we multiply it by the exact same square root, and that gives us a nice 3. Right? It gets rid of the square root. Another way is you can square it, but effectively you're just multiplying by itself. We were given a problem with conjugates, and if we said if we had 1 plus square root of 3, if you multiplied it by the conjugate 1 minus square root of 3, let's see what happens to this. 1 times 1 times square root of 3 is 1 minus square root of 3. And then over here, square root of 3 times 1 is square root of 3. And square root of 3 times square root of 3 is square root of 9. Let's simplify this. Check it out here. These guys are always going to be plus and minus versus each other, because when you make the conjugate, you change that middle term to from a plus to a minus, or from a minus to a plus. And then these always cancel out. See you later. Those always cancel out. And what's the square root of 9? The square root of 9 is 3. So it's 1 plus 3, and the answer is 4 here. By combining this crazy mess, you end up with not a radical answer anymore. So the key about multiplying to get rid of radicals is that, sure, if it's by itself, you can just multiply by its twin. But if it's a binomial, you have to multiply by its evil twin. Okay? Or maybe it's good twin. We change the sign in the middle so that the middle terms cancel out. This is like squaring a difference of two squares where it's a plus and minus. If you remember, if you have x plus 2 and x minus 2, the same effect happens where the middle terms, minus 2x and plus 2x, always end up canceling out, and you end up with just the first term and the last term. Okay? And this is the trick for getting rid of square roots when it's a binomial. Now, this leads us to our next rule for radicals, is that we don't like having radicals on the denominator. The example, if I write 1 over square root of 3, we don't like it when we have radicals on the denominator, so don't leave square roots on the bottom. So we like cleaning them up, making them look a little nicer, and you practiced this in your IXL the other day. So we would multiply this by square root of 3 on the bottom and on top, because that's what our trick was to get rid of square roots. So the bottom would be square root of 3 times square root of 3 is square root of 9, and square root of 9 is just 3, and 1 times 3 is just square root of 3. Okay, so that's how we would effectively move the square root from the bottom to the top, and we won't have a square root on the bottom anymore. Now, here's what we do if it's a binomial, and today is a popular problem that we oftentimes see, actually. So let's write negative 8 over 2 minus square root of 2, let's say. Now you see that the bottom is not just a simple square root. Now I'm going to do some things that don't work. So you can not write this for a moment. If I multiply the top and bottom by just square root of 2, so don't write this, and just watch. If I multiply both the top and bottom by square root of 2, you might think the square roots cancel out on the bottom, but they actually just kind of spread the disease over. This ends up as negative 8 square root of 2 over the square root of 2 gets shared to the front and the back. So the square root goes from the square root of 2 to the front. And sure, the back becomes square root of 2 times square root of 2 square root of 4, and that's just negative 2. And you still have a square root on the bottom. You just moved it over. Well, you might say, oh, let's go just multiply square root of 2 again. All right, fine, let's do it again. Multiply square root of 2 again. And sure, the top becomes negative 8 times 2 now. But the bottom becomes 2 times 2, because square root of 4 is 2, minus 2 square root of 2. It's almost like washing hands with dirty hands. It's kind of hard when their hands are dirty, and you're trying to wash your hands, and one hand keeps getting the other one dirty. That's why you have to wash them both at the same time. They're kind of weird. All right. So as you can see, that doesn't work. So us multiplying by square root doesn't work for these binomials. So we're going to use what we just learned. We're going to, oh, not really learned, but what we've seen before. We're going to multiply this by the conjugate. So 2 minus square root of 2 becomes a plus square root of 2. 2 plus square root of 2. So we're going to multiply that to the top and bottom. We multiply it out, we end up with negative 8 minus 8 square root of 2 all over. Now the bottom, I'm going to take my time right now to write it out. We're going to end up with 4. 2 times 2 is 4. 2 times square root of 2 is going to be plus square root of 2. Oh, 2 square root of 2. I'm sorry. Let me rewrite that. Got a little too excited. 2 square root of 2. Then we're going to multiply the square root of 2's by everyone. Square root of 2 square root of 2. That's going to be negative 2 square root of 2. And negative square root of 4, which is just back to 2. Hopefully you can see here that our middle terms always cancel out. The reason why is because we're smart enough to choose the conjugate to multiply by. And let's go simplify it. Negative 8 minus 8 square root of 2 all over 4 minus 2 is a positive 2. And then we can always reduce this afterwards. Negative 4 minus 4 square root of 2. Okay. And that's really what our goal is today. Our goal is to be able to multiply this out so that we don't have a radical on the bottom. As you can see, the radical disappeared. And even in this case, lucky us, just straight luck that the fraction also disappeared. Okay, so let's try another problem, another example of this. So we have the number 10 over negative 4 minus square root of 3. Right? So we don't like the square roots on the bottom in any form. So in our case here, oops, did I make a mistake here? 8 times 2 is negative 16. 8 times 2 is negative 16. Sorry, are we talking about, someone is asking if I made a mistake. Are you talking about this part right here? For the first example, oh yes, right here. I made a mistake here. You're right. 8 times 2 is negative 16. I just brought over the 8. You're right, thank you for catching that. That's negative 16. If that's negative 16, this negative 16 here. And I'm going to divide that by 2, making that 8. Thanks for catching that. Yep. Sorry about my distributed property messing up. Okay. Okay. So we're going to do this again. Let's go ahead and taking the next problem. The goal is that I can't multiply by just the square root of 3. This isn't enough. Okay, love is just not enough. You need some money here. So if I multiply to the front, you'll see that it actually spreads it to the front. Even though the back is now clean, that does not help us because we want no square roots on the bottom. Not that you're just shuffling around the blame, but we want to really solve the problem. What's the solution? So it's not just multiplying by the square root, but the solution is multiplying by the conjugate. So the conjugate of negative 4 minus square root of 3 is negative 4 plus square root of 3. So take a look here. It's not that we make all the signs different, just that middle term. Negative 4 plus square root of 3. And again, this is just like when we dealt with difference of two squares. If I see x plus 2, remember the change here is x minus 2. And that would eliminate our middle term because our middle terms is what the radicals will still be at. Is where the radicals will still be at. Okay, so we can multiply this now. Let's do the top one is negative 40 plus 10 square root of 3. That's the top. And the bottom's going to be a big mess. I'm going to write it over here first. Right over here. And then I'm going to show you guys again, like normally, the fast way that we should see, the pattern that we should realize that's coming out of this. So we have negative, times 4 times negative 4 is positive 16. Then we'll have a negative 4 square root of 3, a positive 4 square root of 3, and a negative 3 at the end, because square root of 3 times square root of 3 becomes just 3. Do you notice that you always end up with the middle terms canceling out? And really that's what you want to catch. You want to catch that the middle terms are canceling out. So guess what? If we know we're doing the conjugate, we can save ourselves another 5 seconds by skipping it. So this would just be 16 minus 3. And if you want to do 16 minus 3 in your head, you can say 13, sure. So negative 40 plus 10 square root of 3 over 13. And that's it. If I can reduce, great. If I can't reduce, that's just what it is.
Mr. Ko,
Yep, shoot.
I'm a little bit confused where you multiplied the -4 with. So are you supposed to multiply the -4 with the -4 also?
Yeah, so you can think of it as these are just a parentheses. You multiply negative 4 times negative 4 and negative 4 times square root of 3. That's how we end up with 16 and 4 square root of 3. And then it's square root of 3's turn. Square root of 3 times negative 4, and then square root of 3 times square root of 3.
So we're kind of like foiling it pretty much.
We are foiling it. Yeah, we are foiling it. Okay? And the cool thing about this is that when you're foiling conjugates, the middle term always cancels out. See, this term here always goes away. So if you catch that step, you can always just skip it and just write 16 minus 3. So we'll do this a couple more times. Okay. So if I write 9 over 6 minus square root of 5. Okay. Now, we see a radical on the bottom. So I used to make this joke that it's like leaving your pants down. You don't leave your pants down when you walk outside your house. So we have to pick them up. We got to get rid of this radical. Pick up your pants. So we do that by multiplying by the conjugate. And that's going to be 6 plus square root of 5. Now, again, these are multiplying each other, right? But you don't need to write the parentheses. We kind of get the idea. But we are multiplying these terms by each other. So top times top. 9 times 6 is 54. 9 times square root is 9 square root of 5. Okay. On the bottom, it's binomial times binomial. So everybody has to multiply everybody. 6 times everyone in the back, and square root of 5 times everyone in the back. And when we do this, we can take our time and write it. It's 6 times 6 is 36. Then 6 times, let me go ahead and do the steps for you guys. 6 times 6 is 36. 6 times square root of 5 is 6 square root of 5. All right. It is now negative square root of 5's turn. Negative square root of 5 times 6 is negative 6 square root of 5. And square root of 5 times square root of 5 is a 5. So negative, because there's positive and negative is negative. Once again, we see that the middle terms always cancel out here. See that? Middle terms always cancel out. So if you want, you can just do square the front, which is 36, and square the back, which is going to be 5, but don't forget that's going to be a minus 5 because of a positive times negative. We can simplify this. This is 54 minus 9 square root of 5 over 31. Because 36 minus 5 is 31. And can I reduce this? I can't reduce 54, 9, and 31. Which is fine. But if you notice again that if I end up with a negative, give me the conjugate, and that would be 5. How's it negative 5? Great question. If you're looking again at the back, we multiply the back times the back, right? So a square root of 5 times square root of 5 is square root of 25, and that can be simplified to just 5. Because we practiced in our Excel that square root times the square root, you can multiply the stuff inside the square root. So square root of 5 negative square root of 5 times square root of 5, that becomes negative square root of 25, which is now reduced, or not reduced, but simplified to square root of, negative 5. It can't be positive 5 because it would have to have a negative and a negative. A negative times a negative is a positive. If hopefully you guys remember us doing conjugates before from imaginary numbers. So if I gave you guys, we talked about this before, I feel, 1 plus 2i. So remember, this is actually a square root of negative 1. So this is actually considered a radical. And for us, what we would do is we would multiply this by the conjugate. So we would multiply this by 1 minus 2i to the top and bottom. Right? So we multiply the bottom, it would be 1 times 1, 1 times 1, 1 times negative 2, I. 2 times 1, 2i times 1 is just positive 2i. And 2i times 2i is negative 4i squared. If you remember what happens to that I squared is just a negative 1. So we can rewrite this as 1 plus 4, which gives us 5. 1 minus 2i over 5. And that's what we did when we had imaginary numbers that we dealt with last time. So imaginary numbers are radicals, square root of negative 1. So we have to treat these rules when I'm just dealing with radicals the same way. Oops. So let's go ahead and do another problem here. 3 plus square root of 5 divided by 3 minus square root of 5. So remember, we don't care about square roots on the top, we care about square roots on the bottom. So we're going to do everything we can to get rid of that square root on the bottom. And in this case, since it's a binomial with radical, we have a trick to say, give me the conjugate. And we multiply by the conjugate. That should get rid of the square root from the bottom. And it's important for us to know that this is really the only way for us to get rid of that square root on the bottom. If for this problem, just on the side, this is the bad way, okay? Again, we might be thinking about, if I want to get rid of a square root, I have to just multiply by the same square root, which would be seemingly okay. But as we mentioned before, if it's a binomial, it doesn't work that simply. So what if I multiplied 3 minus square root of 5 by its twin brother, 3 minus square root of 5? Would this cancel out? 3 times 3 is 9. 3 times square root of 5 is negative 3 square root of 5. Square root of 5 times 3 is negative 3 square root of 5. And negative is a positive. Square root of 5 times square root of 5 is 25. Square root of 25 is just 5. And it looks very similar to what we would have written over here with our conjugate. Except please note that the middle terms do not clean up. They actually get more nasty. So 14 minus 6 square root of 5, that is way different. And again, this goes back to our Algebra 1 skill of multiplying numbers that you end up canceling out the middle term, like x plus 3 times x minus 3. This, in a sense, is like the conjugate, right? The plus becomes a minus. And when you do this, it's just x squared minus 9. No complicated middle terms. And that's where these square roots will hide. They'll hide in those middle terms. X plus 6, the conjugate here, x minus 6, and we end up with x minus 36. No complicated middle term. And that's why it uses plus and minus. It's a difference of two squares. It's like a little trick here. Because we know that in the end, 5 times 5, they're going to clean up nicely, right? Square root of 25 is 5. And the leftover middle terms is where we have that leftover square root. Okay? So let's go ahead and work on this one more time. So let's do the top first. 3 times 3, 3 times square root of 5, square root of 5 times 3, and square root of 5 times square root of 5, right? Everyone multiplies everybody. This is just distributive property. 9 plus 3 square root of 5 plus 3 square root of 5 plus, we're going to write just 5 because square root of 5 times square root of 5 is 5. And then on the bottom, since it is a conjugate, I'm just going to write 9 minus 5. Right? 3 times 3 is 9, and square root of 5 times square root of 5 is 5, and we just have a negative sign between. Remember, the reason why is if I just write it out, and I didn't want to, but I'm going to do it anyway. Square root of 5 minus 3 square root of 5 minus 5. Take a look. The middle terms always nicely cancel out. We want that. We want those square roots to just go away. And then let's simplify. 9 and 5 on top become 14. 3 and 3 become 6. And 9 minus 5 is 4. And we could reduce this by 2. 7 plus 3 square root of 5 over 2. Okay. Alright. So this is pretty much what you guys will see when you're trying to simplify a radical on the denominator. Either you just multiply it by itself, or you multiply by its conjugate to get rid of it. So we have a nice non-radical number on the denominator. In this case, 2. That's it.